All right. Good morning, everyone. We're going to go ahead and get started here. Today's topic is system architecture and design, just some best practices, some of them well known, some of them not so. Um, Going through this today is myself, Justin Hawes. I'm a solutions engineer based out of Pennsylvania. And then we also have Harry Irvin with us as well.
Hi, everyone. I'm based out in New Jersey.
So we'll get the party started here. So what we're going to go over today, obviously it's 15 minutes, 15-minute feature Friday. So we're going to kind of blow through these relatively quick, but we're going to hit on basic troubleshooting, when to break out different server components, how to scale a project to 10,000 cameras and beyond, basically some scalability issues and concerns, topics to take into consideration. And the last thing we're going to talk about is working with the server calculator to get the best design. So some tips and I don't want to say secrets, but just some quick tips and things that make it more efficient and easier to use. So for the basic troubleshooting, you probably wonder, why is Milestone showing me pictures of flowers? But so this is just a quick memory correlation thing. So FTD, ftd.com, right? Flowers. Anytime we have issues, these are the first three things I go to. The first is the firewall, making sure that you've got ports open. You can actually ping the whatever it is, the camera or the recording server from the client machine that you're on. Make sure that those firewalls are off just for troubleshooting. After you get it working, of course, then you can go ahead and turn it back on and put in the exceptions that you need. Next is time synchronization. This is a big one. Sometimes if there's more than a minute or so, the time difference between the client and the management server, the client won't even let you log in, even if the usernames and passwords are correct. So we recommend using some NTP, Network Time Protocol server. If you're on a domain, it's done automatically by the domain controller. If it's not, if these machines or this environment is not, you can actually use time.windows.com or something like that if they can see the outside. Otherwise, there are third-party, usually software, but there are also hardware components out there too. I think Veracity sells a little hardware device that is just an NTP server. And then the last is DNS. So we see this, or at least I see this most commonly on the client. You're able to log into the client, but you're not able to see any video. And this is generally a DNS between the client and the recording servers not being able to resolve. So try pinging the recording servers or the management servers by name rather than IP. And if it won't resolve and get to those addresses, you can do a quick test or workaround by adding an entry to your hosts file on the client and see if that works. I've had that happen numerous occasions. And if that's it, the proper fix is to have the network administrator correct the DNS entries. So these are I say basic, but 90% of the time when somebody says they're having issues, these take care of it. The next one that I would think about is just compatibility. So operating systems being used. .NET is a big one. We still require .NET 3.5 in addition to .NET 4.7. So I suggest taking a look at the product systems requirement page. This is a great tool. So this is kind of the tip here is just that this page exists on our website. So you can Google Milestone Systems product system requirements, select the product that you're going to use. So you can actually choose. In this case, we're using corporate 2018 R3, but if you're using an older version, you can choose it from the dropdown and the requirements will change. I use this for, like I said, operating system compatibility, .NET versions supported, SQL versions supported, things like that. As far as the CPU, RAM, things like that, I hate that we even list these here because these are basically minimum requirements to run the software with what I say is a 0 or 1 camera. And then, of course, if you scale it up, the requirements for the hardware are going to be different for 1,000 cameras than they would be for 1 camera.
So this is Harry jumping in now. So scalability is one of those things that we kind of pride ourselves in, and being able to scale systems up requires knowledge on when to do that. Milestone, it's a completely modular system, and almost every component is able to have its own dedicated hardware. The first component that we usually look at to break out is the recording server. But what are some rules about when to and how to? So the first reason is throughput. Milestone can handle up to 6,000 frames per second, which if you break that down, it's 200 cameras at 30 frames a second. Now, I wouldn't want to put a piece of hardware up against that limit. So generally, once we hit these kinds of numbers, I usually start talking about installing additional recording servers, having multiple pieces of hardware, or even multiple recording server instances, so you can install the software multiple times on one box. What this allows you to do is it's more distributed video system, and you don't have any bottlenecks when it comes to actual images coming into your hard drives. Another reason for distributing a system is storage. Milestone recommends no more than 20,000 camera recording days per instance. So if a camera records for 24 hours, that's one block of folders, that's one day. That breaks down to 200 cameras for 100 days each. Now, normally, people record in 30, 60, 90-day increments. So that 200 at 100 days is pretty good. And while you can continually add storage to a system, so I can make, my hard drives as I can make an array as large as I want if I wanted to, up to petabytes of data. It's generally best practice to keep these recording locations down to the 20,000 camera days, because what that allows for is for faster rebuild times. Anytime there's a hiccup in the system, we can crunch through 20,000 camera days faster than we can, a million. The next component that we usually separate is the mobile server. This can be done for any number of reasons, but it's mainly to offload video processing and to make the system more cyber secure. When you look at mobile devices, they create endpoints that create vulnerabilities into a network. So controlling that is important. We normally recommend VPNs, or we have dual authentication for mobile devices. There's other ways to do it also. IT teams, they can securely bridge a network into a DMZ where you can drop the mobile server and that can live there. One of the nice things about the mobile server is that we can have multiple instances of that running also, very similar to a recording server. I could distribute cameras across an entire bank of recording servers. I can also distribute mobile users across the entire bank. That way, what you do is you offload and you can have either single or centralized or distributed systems, and that remote users stay on remote networks. The last component we usually talk about is the SQL Server. With XProtect, we give a version of SQL Express that we use to store all of our configuration data or user data, metadata. When that system grows up over 300 cameras, we recommend moving to SQL Standard or SQL Enterprise. And the biggest reason for that is the number of transactions that come into the database are generally, it becomes too many for the Express version of the software. Good thing here is that with large deployments, most of those locations already have SQL running. We have no restrictions about piggybacking off of their system, so we can do that. And then the added bonus is that we have the ability at that point to do scheduled backups with full versions of SQL. So talking about being able to do backups of SQL and everything like that, having the ability to understand when to break out components is important. But there's other things to also consider when you're scaling a system into the thousands or tens of thousands of cameras and devices. What happens when systems go down or into rebuild? How do I manage thousands of cameras? How do I help balance bandwidth between sites? We have a bunch of different tips and tricks that we can work with, but what you start looking at when you get into the larger systems, the first thing is redundancy, and that's where that backup of the SQL comes into play. But also through Microsoft clustering and our own internal failover servers, we can have an entire system protected during a disaster recovery situation. So the management server and SQL servers can be installed over cluster machines. We don't care whether those are physical or virtual environments. And then XProtect Expert and Corporate can have cold or hot standby failovers. So your recording servers at that point can be backed up. And the main difference there, when you're talking about a hot standby, it's a one failover to one recording server configuration. The failover has the configuration of that recording server stored in it. In a cold standby, we don't store that config file. What we do is you can have one cold to multiple recording servers. And when that heartbeat drops between a recording server and the failover will ping the management server, grab that configuration file of the recording server that's down, and then spin itself up and start recording cameras. Downtime is minimal between the two. I know Justin actually ran tests on it, and it was seconds to minutes differences in the thousands of cameras. One of the things you look at, if you look at the slide right here, you'll see a rough diagram on the right-hand side. It's a basic sample layout. In this design here, there was 3 data centers, which are the white and blues in the middle, and then the white on the right-hand side. The way they designed this system, they put the management server clustered and connected to data center 1 and 2. They had the recording servers configured so that half of the cameras are on data center 1 and half of the cameras are on data center 2, with the failovers being on the opposite sides. That way, if one site was entirely lost, they would have live and archive on 50% of the cameras, and then the other half of the cameras would be live only in failover. And then data center 3 was set up to be a complete mirror of 1 and 2. If they were both gone, then 3 would pick up and be able to cover the entire system. So when you start getting up into these larger numbers of systems, how do you start actually building it out? So we start talking about federation and interconnect at that point. With interconnect, what you're doing is you're bridging systems together by devices. So you can take an entire server of devices, recording server, and bring that in to a parent system, and video can be stored locally or remotely. All this is done on an individual device basis with a cost per device. So we have an interconnect license. I can bring from one system into another, bring that one camera in, or I can bring a server and all the cameras in. The difference there is when you go to federation, you're not bridging by device, you're actually bridging by site. So an entire SLC of devices. The system and the entire system, the disparate locations, things like that, are brought into the parent system for centralized management. There's no cost, which is nice when you're doing this on an expert or corporate system. But the issue there is, and then you have to have all locations have to be on the same domain with Active Directory. Because when you start doing that centralized management across disparate systems, you just need to be able to have the users be universal. The last thing that you'll see in that list is SVQR. So in 2016 R3, we introduced SVQR, which stands for Scalable Video Quality Recording. What this does is it allows end users to take advantage of edge storage and recording a high quality video stream at the edge in the camera, and recording a low quality stream centrally inside of a recording server. Then there's the ability to retrieve the high quality video from the camera on either an event or a rule or something along those lines. It can be scheduled or it can be manual. And really what this does in terms of cost reduction is SVQR significantly reduces the network traffic and storage costs that it requires, but you can still maintain extremely high quality video at request and whenever you decide to retrieve that video.
So then the next thing we're going to look at is the server calculator. I think we've done an FMFF in the past exclusively on the server calculator, but I want to just hit a few points here. Like I said, tips and tricks. On the right-hand side, you can see one of the samples, right? So you've got a list of test calculations. I guess the trick here is basically to know that you can actually copy these. So instead of so you have a site, you want to work up multiple variations rather than having to start from scratch. You can go into one that you've already created, or maybe you have a new customer that's very similar to an existing customer. So you can go in, select one, and choose to copy that, and then you're starting from where you basically left off before, your system design that you created previously, and then you can go in and edit that, change the cameras, add stuff, and then make modifications to the other settings as far as it pertains to server, networks, storage, that stuff. On the cameras page, one thing there is those cameras in the dropdown don't actually correlate back to the resolutions and frame rates and things that they support. So right now it's just a list of all of the cameras that we support, all of the frame rates we support, all of the resolutions we support. So by choosing the Axis camera or Sony camera model that you're using, it doesn't hone that information or restrict it, filter it in any way. So me, just to be faster, I just choose OnVIF all the time for I do camera, OnVIF, do O, and then hit tab, and then you can tab down and C for conformant device. And basically you can get through this really quickly. Basically that's the tip of the trick. The key here is that the bit rates need to be accurate. Good data in, good data out. So in this case, we recommend working with your camera manufacturer to figure out exactly what the bit rate that you're expecting to see to the recording server based on the different camera and the different environment that it's going to be in. And then on our camera page, you can toggle the image complexity or even the frame rate if you have to get that bit rate to match exactly what the camera manufacturer thinks that it's going to be. So that way it's apples to apples. We're going to be, creating a server that's going to, absolutely cater to what you need for that installation. On the server tab, a couple things there real quick. I'm actually not showing the different tabs, just speaking to them. Had Paul throw that in there real quick. Down at the bottom, there is an advanced button. One of the things that we like to do here is we can actually choose what kind of storage or connectivity your archives are. So you can actually, if the customer insists that you need to have RAID 6 or whatever for the archives, you can go into that tab and specify that. And then we will do the calculation on the front end to increase the number of disks in order to meet the disk throughput requirement for said number of cameras and all of that. You can also choose to include a management server or not. So if you choose a product that requires a management server, by default, it includes this on the server specification. However, if you're going into an existing install and they've already got a management server, but they just want to add, another 100 cameras or whatever to another phase, you can actually choose to not include that management server because they already have one, so as to keep it nice and clean and not confuse the customer when you give them this deliverable. And I think with that, we're a little over our time. We'll go ahead and wrap it. If there are any questions in the chat, I think we might be able to grab those, maybe.
I didn't see any.
Okay.
Just Marco saying hello.
Awesome. All right, guys. Well, thank you very much and have a great holiday.